Hello, everyone. I've heard that these pre-class videos, they're gaining in popularity, and I'm glad to hear that. I think it's also helping you kind of prep for the class, maybe familiarize yourself with the terminology that you'll hear in class so you're not surprised by what we're going over. For instance, for class 19, we're starting a new module. We're going to alkynes, molecules that have a carbon-carbon triple bond. This one all the way on the right. Okay. And because, well, not everyone is happy with these pre-class videos, but there are enough people, well, two people in particular, who want me to expand the pre-class videos. Maybe we'll have a series and we'll have pre-class video 1, 2, and 3 for every class, and possibly a pre-class quiz. But that's in the future. That's something to look forward to. For today, for class 19, I just want to talk about this figure that's on Canvas, and to maybe encourage you or remind you that you know some of this already. So where does the reactions that we learned in the past 2 classes fit in the whole grand scheme of things? Like I said, our new module is alkynes, but in the previous 2 classes, we've learned how to go from an alkane to an alkene. You'll need reminding how to do that. Let's go from the alkane to an intermediate product. There's only one reaction that you could do with an alkane, which is radical halogenation, and we substitute on the most substituted carbon that has a hydrogen, right? And that would be this one on the alkane right there. Okay. Then how do we get the alkene? The alkene is here, okay? We do an elimination, right? A beta hydrogen elimination. This is review, or it should be review. I'll give you another day or two to look at class 17 and 18. We need a strong base, right, for the beta hydrogen elimination. We could choose NaOH. And look at the name, beta hydrogen elimination. This is the alpha. We have a beta carbon on the left, a beta carbon on the right. But look at the beta carbon on the left. There's no hydrogen to eliminate. We are going to eliminate a hydrogen on the right to make a double bond on the right. Okay. And if you recall, the double bonds between the alpha and a beta carbon, in this case, beta carbon 2. But guess what? To make the alkyne, well, let me tell you this first. Alkyl halide, alkene. We eliminated what? An H and a Br. We eliminated an H and a Br. Not in today's class, but maybe in Friday's class, class 20, how are we going to form an alkyne? You're going to do double elimination, right? If a single elimination gives you an alkene, maybe a double elimination gives you an alkyne. I'm not going to say much about that right now, but that's a preview of what is coming up in the next 2 or 3 days. What is today? Today is down here, okay. And we're going to do some acid-base chemistry. So acid-base is still very important, right? We have to know equilibrium favors the weaker acid. The stronger the acid, the more stable the conjugate base. And the stronger the acid, the weaker the conjugate base is, right? Stability actually equals weaker because it doesn't want to react. It's so stable already. And so we have 2 examples that I show here. And if you look at the pKa table or memorize the pKa's, what do we know about water? It is pKa of 15.5. I'm really hoping that you are memorizing these. This terminal hydrogen on the far right here. Let me write this better. There's a carbon there, hydrogen there. I think on my pKa table, that's a pKa of 26. Look at that. Going to the left. But if you use a stronger base, such as this, NH2 minus, remember, you got to separate the salt. Well, why do I think that's a strong base? Because we get a very weak acid, right? Weak acids give you strong bases. Strong bases give you weak acids. pKa equals 36. Beautiful. Because now, with the alkyne being 26, we get the equilibrium now to the right. So there's acid base that we're going to talk about today. And then finally, well, after acid base, we're going to talk about alkylation. Okay, if there's anything you will need to know about alkylation right now before class, is that this carbon is the attackee. Maybe I should tell you the attacker. The attacker is this lone pair. Okay, we take the alkyne and we remove the hydrogen, and the alkyne anion hits that carbon, kicking up bromine. And where's the red carbon in the product? It's right there. The bond that you made is right here. Bond made. We're getting into some very interesting reactions. This is our first reaction where we bring two pieces together via a carbon-carbon bond. Making carbon-carbon bonds is one of the more useful transformations that we'll use in organic chemistry. It's how you build up molecules through carbon-carbon bonds. Is the most popular way and the most useful way to make functional molecules. Okay, this one was a little bit short. I'll make the next one longer, and to give you more information. I think that's good. That's a good study sheet, actually, for class 19.